From the login screen, we just have 3 user accounts here. 2 of those are for you guys to use. The CTL account is really just reserved for us to use if we need to like troubleshoot something. There's some tools on there that we don't give access to the end users for safety reasons and stuff. So the admin account and the user account are going to be your guys' to use. That being said, there's no real advantage to using the admin account over the user account. The admin account would be more for if your IT team wanted to connect this to the network, to a domain or something like that. It would give them the necessary elevated privileges that would allow them to make those changes. So for you guys, for your guys' use, I would stick with the user account unless of course you have IT add your individual user accounts, and then you'll be able to log in that way. But for now, it's just going to be the user account. So I'll go ahead and log into the user account, and the password for this is just pass, all lowercase, PASS. I see everyone brought pen and paper. I will just disclaimer, I'm going to actually, I've already put the quick start guides on the in this manuals folder here. On the desktop of each of the user accounts, there's a manuals folder, and it contains the software manuals, which are very comprehensive, lots of information in there, software-based information and scientific-based information. So it can be sometimes a little bit hard to parse through all of that and find just like exactly what you're looking for. So that's why we went and made the quick start guides as well. Those will be in the quick start guides folder. And really all that is, it's just a written form of the training that I'm giving. So if you need a refresher on anything that I'm talking about today, quick start guides are my recommendation for where to go with that. So when you first log in, typically it's supposed to go to the switchboard. I don't know why it didn't there. This would typically be what would pop up first. It's just the main menu for the CTL software. Now, if it doesn't come up for some reason, the desktop icon is just right there down at the bottom called Switchboard 2.7. So if you need to open that via the desktop icon, that's perfectly fine. But like I said, this is just, think of this as your main menu. There are multiple pieces of software installed on the computer that all serve different purposes depending on what you're trying to do. So the typical workflow that we would observe would be, you're going to scan a plate, you're going to generate the individual well images, and then you're going to open that plate, those images up into the counting software to count the spots in the wells. And then optionally, after counting, you would potentially open quality control. Quality control will give you some functions that will allow you to, say, remove individual spots that got picked up as a spot, but you don't want to be counted as spots. So maybe they wouldn't be actual spots. Maybe you had like a piece of dirt in one of the wells or something like that that was detected as a spot. Quality control would be where you would be able to remove something like that. It's not good for big sweeping changes, like if you were getting subpar results for the entire plate, then you would probably want to go and reevaluate your counting settings in the counting section. But for like well by well changes, quality control serves that function very, very effectively. So, and then the last thing that I will go over would be the manage data function, which really just compiles the information that you gathered in the scan, count, quality control steps, and then allows you to quickly open that data and view it. Allows you to do some things like exporting to PowerPoints. You can generate some well images and put it in a PowerPoint format, and then use that for a presentation. The other functions that you'll see here, plan experiment, that would allow you to create like a plate layout. It will allow you to specify what reagents are going into what particular wells. It will also allow you to print barcodes off for your plates that can be read by the machine when you go and scan a plate. Statistics, that is what it says it is. It just gives you some statistical information on the counted results that you obtained during the counting step. Now, there's an Excel spreadsheet that gets created after you count a plate and after you quality control a plate, and that contains some statistical information as well. Generally, that Excel file contains all the necessary information that most people would need to use, but the statistics will kind of go a little bit further and add to that data if you find some use in analyzing some of that information. So right now, up in the top left of the switchboard, you can see we're in the Biospot suite. The Biospot suite is going to be for viral plaque assays. That being said, what do you guys plan to do more of? Do you plan to do viral plaque assays? Do you plan to do visible light enzymatic assays or fluorescent assays? If you had to take a pick, or not sure yet.
In our lab, we are doing. I'm not doing it, but we are doing a lot of viral plaque assays.
Viral plaque assays? Okay. Is that everyone or?
Well, I'm not sure if we are going to be implementing other assays as well. Like, this is something that still haven't been decided.
But without a doubt, you will probably use it for viral plaque, if nothing else. Okay. So the reason I ask is the Biospot suite is a bit different than the other software suites. Particularly the scanning section is different in that it uses a different type of scanning software than if you were conducting a visible light enzymatic assay, if you were conducting a double colored visible light enzymatic assay, or if you were conducting a fluorescent assay. So I guess I could talk about both scanning software, but I will start with the Biospot suite and just go over that. There's going to be a lot of carryover. The interface is going to look different, but at the end of the day, you should understand the concept of both the software pretty well. So, if you weren't doing a viral plaque assay, what you would want to do is you would want to come down to this Switch Suites button down here. And then if you drop down there, here are the different switchboard suite options. So first, we've got the Elispot SC suite. That's going to be for visible light, single color, hence SC, single color. Assays, Biospot, as I said, that was viral plaque. Elispot DC is for Elispot double color, so that's going to be for double color visible light assays. And then Elispot Fluorox is going to be for your fluorescent applications. So I will keep it on the Biospot suite here. And then the one other thing, scan and count, just consolidates the two scanning, or the scan and count separate steps. It saves time once you have individual scanning and counting parameters set up for your particular assay. So you're going to need to do the individual steps before you get into scan and count, because you'll have to have already gone through setting up a scanned image template for your particular assay that looks good, and then you'll have to set up a counting template for your assay that also effectively counts the spots in your plates. So once you've done those two steps, you can use the scan and count feature, and that just, like I said, consolidates the two steps and makes things go a little quicker. So I will start with just the scan function, and whenever you're doing a scan, you're going to need the actual analyzer itself to be turned on. So that's just done by flipping the red power switch there. You can hear things start to spin up inside, and then the two LEDs up at the top light up to indicate that the machine is turned on. And then once it's turned on, I can hit scan, and it will go through, and the computer's just going to talk to each piece of hardware in the machine and make sure that everything's initializing properly. And then once it does that, it will send us through to the scanning software.
Does it matter whether you start the software or the machine itself first?
You should start the machine. Definitely turn the machine on before you click scan. If you're real quick with it and you hit scan, but the machine's not on, but then you quickly flip the power switch, it might be fine. but if you wait too long, that first piece of hardware that it tries to talk to, when it's not able to talk to it, it will tell you that, doesn't really tell you the machine's turned off. It tells you some obscure error message that doesn't necessarily indicate that you just need to turn the power switch on. I think it's a stage XY error, which means the stage is the thing that actually moves the plate around inside the machine. If you see that, just make sure that the analyzer's turned on, exit out of it, flip it on, and then go back into it. So once it goes through that list of initialization, it sends you back to here. This looks like the switchboard, but now if you look at the top left, there's this little capture icon with a little red desktop icon. That is the Immuno Capture software, and that's the scanning software for the Biospot suite. So all I want to do here is I just click scan. It's going to ask me if I want to do a full plate scan, a partial plate scan, or a strip scan if I were to use strip plates. I will just select full plate scan. And then once we do that, this is our scanning interface. So first thing that I always recommend doing once you're in the scanning software is selecting this dashboard icon, and that's going to expand the options that you have to select prior to starting your scan. A lot of these are very important, so that's why I expand it. If you're using multiple different assays with the machine, odds are this first option, the capture format option, is not going to necessarily be correct. What the capture format option is it's just the physical layout of whatever plate it is you're trying to scan. So it contains things like the zoom and focus of the lens to make sure that the wells are properly zoomed in on and properly in focus. It's going to contain things like your color settings so that the spots are nice and distinct on versus the background of the plate. And you know, if you're counting blue spots, you don't necessarily want a blue background. You would want a nice neutral background that made it so that the software was easily able to identify the spots. So all of that stuff is going to be contained in the capture format. So if there's one thing to remember, it's make sure that your capture format is set appropriately prior to starting a scan. Right now we're set to the reference plate capture format, but if I select the drop down box, there's several different options here. These were all set up at CTL with the plates that they're named after. They're just generic templates. It doesn't necessarily mean that if you were to use one of these plates for your assay that everything will look ideal. Odds are what will happen is the actual alignment of the plate itself will look good, so your wells will scan nicely aligned, but the colors might be off, so your assay might, like I said, contain blue spots, whereas maybe the assay back at CTL we were using the same plate with totally different colored spots. You might need to modify those, which I'll get into in a little bit. But for right now, I'm going to keep it on the reference plate because I have that on hand. So this is the reference plate. It's typically used, now you didn't see the option back on the Biospot switchboard suite, but if I would have flipped over to say the Immunospot SC suite, there would have been a little spot icon that said Qualify Analyzer. That is what the reference plate is used with. It is a qualification software that will go through, scan this plate, and then compare those results to the baseline data that was generated with this plate. And if the spot count deviations don't exceed a certain percentage, that qualification will pass, just to tell you everything seems to be working with the machine. It's a totally optional feature that you don't necessarily have to use. You guys have the express qualification, so rather than scanning the entire plate, it just scans in like an X orientation and then just compares like a handful of wells. But once it completes, it takes about 20 to 30 seconds. It will just pop up and say whether it passed or failed. And if it passes, then you can rest assured that everything's working well. If it fails, there's a couple of different things that you could, well, actually with this machine, the only thing that I would say that might cause it to fail would be if you didn't insert the plate correctly into the machine. So there's a specific orientation the plate needs to be inserted. I'll show you once I actually insert this plate. But that would be the one thing that would probably most likely cause this to fail. Otherwise, you might be looking at some sort of hardware error that we would have to troubleshoot. So that's when you would reach out to us and tell us, hey, our reference plate's failing, and then we, if we could, we would connect remotely and start to investigate that. So, so I will keep the reference plate selected, and then I'm going to go ahead and load this plate. So what I'm going to do is I'm going to click the eject button here, and then from the left side of the analyzer here, the plate holder is going to eject. If everyone, I don't know, squeeze over here, but pretty simple. There's a little red sticker on the plate holder there that indicates which side that the A row is supposed to be oriented in the plate holder. So row A, there's my row A, and I just want to set that in there like so. Like I said, if you were to set it in backwards, the scanned images are probably going to come out misaligned for one, and then obviously once you like see an overview image of your plate, the A1 well is not actually going to correspond to the A1 well. It would be the H12 well, or yeah, A12 or H12, yeah. So everything would be backwards and lead to a lot of confusion. So make sure that's oriented correctly. Once it's in there, I like to snug the plate up into this bottom left corner here. Only reason is because this little arm is going to come and snap that plate into place once it goes into the machine. Just gives it less room to move. So once you do that, you can come back to the software. It asks you for a plate name right now, since we have a prompt for plate name up. Now there is a barcode reader option like I was alluding to earlier, which would not cause that to pop up, and it's just going to read that barcode there. But since it's asking us for a plate name, we could just type in a generic name here. I'll call it rough test. Click OK, and then click load. And then there is your well image. So by default, the software goes to the A1 position. So this is our A1 well. Like I said, if that plate was backwards, that wouldn't necessarily be the A1 well, even though it said it was. So just make sure of that. And then just going down this list of the options in the dashboard, the next thing you have is selecting a path for the plates to be saved. So right now it defaults to D plates. Always recommend saving all your plate scans to the D drive. There's two drives in here, the system drive, system C drive, and then the D drive. If you overfill your C drive with a bunch of plate data and stuff, and there's very limited space on the C drive, that can lead to just a slowdown in general of the operating system. So that's going to be less than ideal for smooth software operation. So like I said, always save it to the D drive. You can create as many folders in the D drive as you want. So if I click browse, expand computer, go to D, the plates folder, that's, as you can imagine, where we would typically recommend saving the plates. And then from that plates folder, you can create your own folders. So I've already created a folder, CTL IQ. But like I said, you're free to create as many as you would like within there. I will select that IQ folder. I'm gonna sit down because I'm having a hard time seeing the screen from that angle, but so the next option is our centering mode. So as I was saying earlier, with your capture format, all the physical proportions of your plate are saved. So that includes the actual physical layout of the plate and all the wells, so that when it scans, this region of interest here that you see by the red circle is nicely centered on the edge of the well. Now you might ask, it seems like it's a little zoomed in. That's generally because you start to get a little bit of reflection off the edge of the wells, and so we tend to bring that ROI in just off the edge, just to compensate for that, and make sure that we're not capturing any reflection. Now with the centering mode, this helps to correct any small discrepancies with the alignment that is saved for your capture format. So right now we have this auto pre-alignment user verified function selected. What that's going to do is once you start the scan, it's going to go to the 3 corner wells, A1, A12, and H1, and it's going to do an auto alignment on each of those wells to try and bring this into a better alignment if possible. Once it auto aligns, the user verified aspect of it is going to pop up with a little box, and it's going to ask you if you accept that position. If you like what it came up with for the centering position, then you could select OK. It will move on to the next of the 3 wells, auto align, and then ask you if you want to confirm that well. If you don't like the position, it will pop up with some directional arrows and allow you to actually move the plate around in the machine to adjust this. So if you don't want to use the user verified option, you can just use the auto pre-alignment option, and that will get rid of that little dialog box that asks you to confirm. It's just going to automatically go to all 3 wells and align on them, auto align on them. Generally, in my experience, it does a really good job. If it's a visible light plate, if you're able to clearly see the well, odds are it's gonna work fine. If you have a plate where it's very hard to distinguish the edge of the well, the easiest example I can give of that is a fluorescent plate where it's just black, the background is black. It's not going to be able to see the edge of the well, and thus it's not going to be able to auto center on it, and that will cause errors and stuff like that. So if you've got a visible light plate, you could probably get away with auto pre-alignment pretty much every time. So the top option there, fixed preset positions, that is not going to use any smart auto centering software features. So it's just going to use the saved alignment features for the capture format that you have selected. So that would be the quickest option. It won't waste any time with the auto centering, but if you have a slight misalignment with your plate, it's not going to correct that, and it could, if it's severe, if it's cutting off a portion of the well, then you're not going to be able to capture that portion of the well in the scan. Then going further down the list, we start to incorporate what's known as auto centering, not to be confused with the auto pre-alignment. Auto centering is, instead of just auto aligning on the 3 corner wells, it's now going to auto center on every single well across the plate. So fixed preset positions with auto centering means it's just going to start in the fixed preset position that's saved to that capture format, and then on every well that it scans prior to taking the image, it's going to auto center on that well. Once you go further down the list, then it starts to incorporate the auto pre-alignment with the auto centering. So now you're adding more time by first doing an auto pre-alignment and then doing auto centering on every subsequent well that gets scanned. So the idea here is just that the top option, fixed preset, that's going to be the fastest way to scan your plate, but it's also going to be the least accurate in terms of the alignment. As you go further down the plate, it's going to add a bit more time to the scan, but it's also going to add more accuracy to the actual alignment. So it's up to you what you decide to use there. Like I said, if you've got a visible light plate, auto pre-alignment is pretty quick, doesn't add a lot of time, and it usually can only help rather than hurt. So that would always be my recommendation. So moving on to the exposure options. Preset value is what is currently selected there. So that just means it's going to use a fixed exposure value for every well on the plate. That fixed exposure value is taken from whatever is saved to the capture format. That's something you can adjust with your capture formats. So it's not going to vary the exposure on a well by well basis. It's just going to use the same value for every single well on the plate. Whereas if I switch it to auto exposure, now it's going to auto expose on each well across the plate. Obviously, like auto centering, that is going to add more time to the scan, but if you have a plate that varies in, I guess, the brightness of each of the wells, so maybe these wells over in the top left of the plate are bright with very few spots in them, but then when you get down to the bottom right, you have very dark background and a lot of spots. Maybe auto exposure could help to alleviate some of that issue and get it to be more consistent across the entire plate. Generally, in my experience, most people just default to the preset value, just because there's not a lot of variation in the exposure across the plate. So And then the last option, user defined, this just allows us to set a fixed exposure for this one particular scan. So it will allow us to either type in a value here, or we can use the slider bar to increase our exposure or decrease our exposure. And then once it scans that plate, using that defined exposure value, it will revert to the original value that's saved with the capture format. And then the last option here is just the well selection. So this we kind of talked about before we got into this window, but that just allows you to define whether you want to do a full plate scan, meaning for this plate, all 96 wells, a partial plate scan. So if we select that, it pops up with this window that will allow us to define which particular wells we want to scan. So we can just select them. As you can see, it's starting to highlight those wells. We can also select individual columns by selecting the number of the column we want to scan. We can select individual rows by selecting the letter of the row. Or if we want to select or deselect the entire plate, I can just select the summation button up there, and that will select all wells in the plate. And then deselecting, you just click to deselect them. So, and then strip plate, like I said, if you're using a strip plate, this is just going to, when you select something, it's just going to scan the entire strip rather than selecting an individual well. So I will scan the full plate. Let me just, I guess I'll do that scan right now and then tell you about actually adjusting the capture format. So once we have set everything up in our dashboard, assuming we have a capture format that exists for the particular assay that we're using, then we're good to scan. So I can click start. And since I already named the plate, it's gonna not prompt us for a plate name. If I hadn't named the plate when I loaded the plate, it would ask me for a plate name. And then this is the user verified function. So this would be when I would either be able to adjust my position of the well. I can move left and right. I can adjust my step size so that it doesn't jump as far. So now it's going to make smaller jumps. Even smaller jumps, 10. And then once I'm happy with it, I can just click confirm, and it's going to move to H12, or A12 rather. I'm happy with that, so I'll click confirm, and then H1, with that, click confirm, and now it will actually go through and start the scan. Any questions so far about setting up a scan?
So this is auto pre-alignment, not auto centering, right?
This is auto pre-alignment user verified. So the user verified thing was just that box that says confirm or allows you to move it. If I would have selected just auto pre-alignment, you wouldn't have seen those boxes. But yes, the auto centering, if we were doing auto centering, rather than just quickly, you could see once it moves, it just acquires the image and moves on. With auto centering, there's going to be a brief little period of time where it's going to shift the image just ever so slightly and then acquire the image. So it doesn't add a considerable amount of time, like maybe a second per well or something like that. But you know, if like I said, if auto pre-alignment's working, it usually does a pretty good job, and auto centering really, it's just kind of redundant at that point.
Is there auto centering verified as well?
Yeah. There's auto pre-alignment, user verified with auto centering. So it's gonna do what it just did there, where it goes to the 3 corner wells and asks you to confirm them, and then it's gonna subsequently auto center on every single well across the plate. It's not gonna, it won't prompt you to adjust on every single well if that's what you're asking. No, yeah, that would, oh boy, that would be annoying. I just count the plate by hand at that point.
Is the plate moving or is the camera?
The plate's moving, yeah. So once it's finished, it gives you a 96 well image overview there. So you can just close that, and then you're back to here. So now if we had more plates to scan, we could just eject, load our new plate, and repeat that process. If it was the same type of plate, odds are we wouldn't have to adjust anything, just type in a new plate name. But if you don't already have a capture format set up for the experiment that you're conducting, then you're gonna wanna create a new one. So I will show you how to do that. So first we're gonna go to advanced settings. You can also get to this window from file, settings. You're gonna go to capture format selection. Before I do that, on this window, this is where you can select your naming mode. So right now, we're prompting for the plate name, so that's why it tells us to type in a plate name when we load a plate. If we have barcodes, we can select barcode reader, or if we want to let the software auto name our plates, we can select auto naming. And then auto naming is going to use this format here, so the base name is going to be plate underscore, and then it's going to start with 00, and then go up by 1 after that, and then you can modify that if you want, but I'll leave it on prompt for plate name for now. So I'll go to capture format selection, and then whenever you're creating a new capture format, what I always recommend is start with one of the existing capture formats that most closely resembles the plate that you're about to create. So if one of these capture formats, say you're conducting an experiment on an MSIP4W plate, there is an MSIP4W template right here.
Yeah.
So if I just select that, it's gonna switch, barely switched because, well, yeah, now you can see the alignment's off, but the reference plate does use an MSIP4W plate. So, so like I was saying, select the capture format that most closely resembles the plate you're wanting to create, click edit, and then instead of overwriting this existing template, I always recommend duplicating it, just so you can revert to that original if you ever need to. So in order to do that, once we get into this window, I just come to this duplicate button, click that. And now it creates this copy of Millipore MSIP4W template. So that's right here. And then obviously that's a pretty generic name, so you can rename it up here with this plate profile name window. Since it's just a test plate, I'll leave it as is. And then from here, this window just allows you to customize all of the image settings. So starting up here in the top right, we have the exposure value. So this is what's going to be the defined preset exposure value that gets used in the software when you select preset exposure. So we can increase that by dragging the slider bar. You can type in a numerical value. You can let the software try to auto expose and come up with its own exposure. Going further down this list, you start to get into the color settings. Now, I would recommend, if you need to make color adjustments, using this white balance feature before you get into actually tweaking individual RGB values, just because the white balance generally does a good job and it's less cumbersome. So if I were to select white balance, this doesn't really need white balance, so I kind of made it orange, but it's just going to try and make your spots stand out more versus your background. So if you've got a background that's very close in color to your spots, and when you go to count your plate, it might start picking up background and counting that as a spot when you don't want it to, then odds are you need to make some color adjustments, and white balance is just the easiest way to go about doing that. If it works well the first time, you can use that and move on, but if you need to, then you can come into the individual RGB values and start tweaking those. Gain and gamma, you don't typically need to adjust those, they just generally make the image darker, brighter, but RGB values might need to be adjusted. So if your spots are out of focus, you can come down here to the focus window and you can adjust your focus by either typing in a numerical value or dragging the slider bar. If you see it, if I drag that, now it changes the focus of the image. If I want to do an autofocus, I can click auto. It does not allow you to adjust the zoom, even though there is a motorized zoom in this machine. If I were to authenticate as like CTL staff, it will allow me to adjust zoom, but the thought is that you shouldn't need to adjust the zoom because there should be a capture format here that will correspond to your plate type. So for instance, if you weren't using a 96 well plate and maybe you were using a 384 well plate, there's a template there for it. There's a 48 well template, 24, 12. So the likelihood of you needing to adjust the zoom is small, but if you find yourself really needing to make that adjustment, let us know and we can either remote in and make the adjustment ourselves or come up with a temporary password that will allow you to authenticate and then make the zoom adjustment. So sometimes if you are doing a viral plaque assay, for instance, you might be using clear plates rather than opaque white plates. Those will typically benefit from using the bottom light source instead of the top light source. So for instance, if I were to switch to a clear plate, which might be 96 well BD Falcon. Yeah. So you see when I switch to 96 well BD Falcon, which is a clear plate, it switches to the bottom light.
Yeah, automatically, right?
Yeah, it just provides a better image, but not saying that every clear plate will need to use the bottom light, but you might want to experiment with both. The UV, those are only for fluorescence, so unless you're doing fluorescence, you shouldn't need to toggle any of that. So I'll come back to my copy here. Most of this stuff up here shouldn't need to be adjusted. It's specific to the layout of the plate. So 96 well plate is going to have 12 columns, 8 rows, and there's a specific region of interest radius that needs to be set. So you shouldn't need to worry about any of that. The only other option here that you'll probably need to take advantage of is the stage settings window down here. So as you can see, this plate is not aligned. So if I were to scan this plate right now, if I used fixed preset positions, this is the image that it's going to capture. So it's not going to capture the entirety of the well, and then it's going to capture some of the outside of the well. If I use auto pre-alignment, it will probably correct this and bring it into a proper alignment and scan nicely aligned. But if I don't want to worry about auto pre-alignment fixing this mistake, what I need to do is perform what's known as a 3-point alignment. So that essentially is just the manual, conducting a manual auto pre-alignment. So I'm gonna go to the 3 corner wells and I'm going to manually align on those 3 corner wells and tell the software this is specifically where those wells lie. And then from then on, every time you scan this plate, even if you were to use fixed preset positions, it should be nicely aligned and you shouldn't have to worry about making adjustments with auto pre-alignment. So now, there's 2 ways to do this. You can use these buttons here. If I click A1, the A1 text, it's going to go to the A1 position. It's already there. This is what it has saved for A1. So then I need to come over here and I need to manually adjust this. So once I'm happy with that position, then I just check the box, and that confirms to the software that that is in fact the A1, the new A1 position. And then I just repeat that step for A12. One important thing about this process is if you've got a plate type here that is so severely misaligned that when you click A1, it goes to a position that might look like it's on a well, but it's not in fact on A1. What you want to do is you want to, so using A12 now as an example, if I want to verify that this is in fact the A12 well,
Move to the right.
exactly. I know there's going to be no wells to the right and there's going to be no wells above it. So I'll just increase this step size to make it jump a little further, and then I'll move, and I know I'm clicking left, it moves the image to the left. It's a little counterintuitive, but it starts to make sense after you've done it many times. So I can see, if I come up there, that is the top of the plate. If I turn down my exposure, sometimes you can actually see
The edge.
yeah, you could see the number, the letter on the edge of the plate. So, but that just confirms to me that that is in fact A12. So now I'll just come back down to A12. I'll expose that to make it back. Alright, we'll call that okay, and then repeat that with H1. And then once I check that box, that's all you need to do. All you have to do at that point is save all the changes, which is done by clicking apply changes and then clicking OK, which that's not just specific to that, that saves everything you've done in that window. But now when I go to another well in the middle of the plate, you can see that it's nicely aligned, it's not off-centered. So the other way that I could have done that was by clicking auto alignment, and this is pretty much just going to go through the auto pre-alignment user verified feature, where it's going to do an auto alignment itself and then ask you to adjust it. Since I'm happy with that position, just click confirm, goes to A12, auto adjusts, asks me to confirm. And this is nice. It obviously is a lot quicker, but like I said, if you have a plate that is so severely misaligned that it's not even going to the correct well, it might auto align on that well, but even though it went to what it was calling A1, it might have actually been on B3 or something like that. That's going to throw off the entire alignment of the plate, and so you'd only be able to correct that by manually doing that alignment yourself. So, any questions about modifying the capture formats? That's pretty much the extent of that process. So, all right. So, I can click apply changes. Click OK, and then it throws me back to this window, and I would just want to click save and exit, and that would save all those changes that I just made. The only change that's not going to be saved, you need to exit out of the software and go back to it, is the plate name. So if I would have adjusted the plate name, it would have still shown up as copy of Millicor MSIP4W until I exited out and come back in. But everything else, like as you can see, the alignment's corrected and stuff. So everything should be good to go apart from the name. So I am going to delete that just because it's not really serving any purpose. So I'll just go highlight it and then click delete there. Click save changes. And then we're just back to our normal setup here. So yeah, so that's ImmunoCapture scanning software. So, any questions about anything in terms of scanning in ImmunoCapture? Everybody good? All right. So I will get out of here since I've already scanned the plate. Actually, I'll keep the plate in the machine instead of ejecting it for now. You can either click back to switchboard, or you can go to File, Exit. Now, I typically like to go to File, Exit. That will take you all the way back to that main switchboard. However, I know this is not intuitive, but if I click back to switchboard, it takes me back to this window, which is still in the ImmunoCapture software. The reason I point this out is just because if I were to now go to the counting software, which uses an entirely different software, not ImmunoCapture, it uses the Elispot counting software. Since there's an instance of ImmunoCapture running, and then you try to open up an instance of Elispot running, sometimes it can create issues. I think that has been sorted out in recent revisions of the software, but I always like to just make that disclaimer in case you run into that issue in the future. So if you're not sure, I always recommend just exiting out of here and going all the way back to that main switchboard window, which just says CTL switchboard, and it has the little gray switchboard icon. And from here, I can now go to count. Now count is pretty much, you're pretty much going to take what I'm telling you and counting with Elispot and apply it to any of the other pieces of software. So if you're doing a visible light assay, if you're doing a visible light single color assay, if you're doing a fluorescent assay, counting works pretty much fundamentally the same across all three of those. Now, a double color visible light assay is totally different, but not a lot of people use double color, especially ones that have a fluorescent machine, because why subject yourself to only 2 colors when you can have, I don't remember exactly, this one might have 12 different colors that you can do in fluorescence. So, but that being said, this counting explanation should apply to fluorescent and single color visible light as well. So once we click count, now you can see we're in the Elispot software. Green icon says Elispot, and then we have several different counting functions that we can select from. Template count is going to be if you already have a counting template set up for the assay that you are about to count. That is not the case for us. We need to create a new template, but if you had already done that, template count will just allow you to quickly load that template and then select the plates that you want to be counted and go and count those plates. Auto count wizard and smart count. They both function vastly the same. Now, if we were in Elispot, if we were in the Elispot SC suite and we click count, this is going to be called smart count wizard, not auto count wizard, but I'm 99% sure they're the same function. The wizard is just a guided process through this smart count feature, and what smart count is it's going to pretty much give you full control over the counting parameters that you have, that you're able to use to set up your counting template. However, there's going to be one counting parameter that it's going to automatically set for you, and that counting parameter is called the sensitivity. The sensitivity is a measure of how many pixels are being picked up and detected as spots in the plate. So essentially, the higher you set your sensitivity, the more spots it's going to pick up in your plate. The lower you set the sensitivity, the less spots it's going to pick up. Smart count and the auto count wizard, they're going to automatically set that sensitivity parameter for you, and they're going to set it on a well by well basis, so it can potentially vary that sensitivity value for each well on the plate. If you go further down the list and you go to basic count, this just gives you full control over everything. Even though basic would not indicate to you that it will give you full control. I don't know. I would think that would be more like an advanced count, but that's besides the point. So, yeah. So it's going to give you control over all the parameters, including the sensitivity. So you can adjust the sensitivity yourself. Now, instead of being able to adjust the sensitivity on a well by well basis, like Smart Count was doing, that sensitivity is just going to be applied to all wells across the plate. Generally, that's not a problem. Most people that I know like to use basic count. Some people do use smart count, but it's up to you if your particular assay benefits from varying that sensitivity value. So basic count is what I'm going to show for the training, just because if you understand adjustment of the parameters within basic count, all the other functions are going to make sense to you. And then multi-set count, that's going to be if you have multiple assays across one plate. That's going to allow you to set up 2 different sets of counting parameters or more for one particular plate. So I can set up one half of my plate using one set of counting parameters, the other half using an entirely different set of counting parameters. And then one other thing I'd like to point out before going into the basic count is the object type. So if I go to objects up here, depending on the size of your spots and I guess how they look, you might want to vary the object type here. So by default, it goes to normal, which, as you can see here, is dark spots over a light background. That would be what we were scanning with the reference plate. It was dark blue spots over a neutral, brightish background. Another option is normal with diffuse spots. So if we had particularly diffuse spots, which was not the case with the reference plate, the reference plate actually is not a viral plaque assay, so it's definitely not diffuse. But if you have a viral plaque assay, you might tend to have more diffuse spots. Then you might want to select the second option down. Then you start getting into the inverted options. Inverted refers to the color of the spots versus the background. So with the normal options, we had dark spots on a bright background. With inverted, we're gonna have bright spots on a dark background. It's gonna be very evident to you once you go into the counting software whether you selected the right one. Because if you have a plate with normal spots, like the reference plate with the dark blue spots on a bright background, but you select inverted, it's going to start counting all of the empty area and not count the actual spots. So it's going to be pretty obvious right off the bat that you selected the wrong thing. But inverted, if you have the opposite of normal, and then you have the diffuse option as well on inverted. And then you start getting into some more rare cases like ring diffuse spots, which are like donut shaped spots with a bright center to them. They would be dark circles with a bright center. Inverted ringed, I guess that would just be the opposite of that. I don't know that I've ever seen that before. Detailed would be if you have very fine small spots. Also, I feel like that's kind of rare in a viral plaque assay, but I don't do much viral plaque work, so I couldn't say for sure. And then inverted detailed would just be the opposite of detailed. So you're gonna have bright spots on a dark background, very small though. So yeah, if you need to make some adjustments there, you can. If you start with normal, and then you notice that, so let's say you had like really diffuse spots, but you have a normal spot layout. So you have dark spots on a bright background. You start with the normal option, not the diffuse option, but you start to notice that your spots are being broken up into multiple spots. So like you have one large spot, but it's getting split up into a bunch of individual spots. That might be an indication that you need to select the diffuse option, and that will change the spot detection so that it accounts for the size of those diffuse spots a little more accurately. So once I click basic count, it sends me to the counting software. I can now load my plate. Click load plate, navigate to the location where I saved it in the scanning software, which was the CTL IQ folder, and then I want to make sure that I select the ref test folder, or the folder of the plate name that I typed in the scanning software. If I click the plate name, you can see that it generates a little plate overview here. It tells me my plate name. That indicates to me that this is a valid file path to be selected for counting, and then I can just check the box and that will load it into the software. If I instead were to select the path of not like an incorrect path, you're going to see that it's not going to generate a plate image, and it's going to say not a plate. So I'm not going to be able to select that box because it's not the proper file.
What if you have multiple plates in the same folder?
So like if I had, well, this is a fluoro folder, so I'm not going to be able to select that. But if this was a visible light, I could just check. I would have to check.
Yeah.
Like I couldn't check the if you're.
Oh yeah.
Yeah, I couldn't check the parent folder of all the underlying folders there. I just have to individually check those folders within there. So. But yeah, just check the box next to the plate name. Click select, and then it loads the plate for counting. If I already had counting parameters set up for this particular plate or this particular assay, I would come here and I'd click load parameters, and then I would see the parameters in this list. I would select them and then click load. Obviously that's not the case, so I'm not going to do that. Instead, I'm going to want to set up new parameters, so I'm going to come down to this fine-tune params option, and then this is where I'm going to do all the busy work with counting. So these are all of the individual counting parameters that are going to be factored into the spot counts that I obtain when I do a count of a well. So if I want to check what I'm counting currently with just default counting parameters, I can double click on the well, and that will do a test count. So I can double click, and you can see it's just test counting along the wells. If I click count down here, that's also going to do a test count of the well. Like I said, these are just default parameters. They are in no way specific to this particular plate. It's not doing any type of smart counting or anything like that. It's just going to use the same thing every time you load the software. But that being said, it's really not doing a bad job of detecting the spots currently with these default parameters. So just to help you visualize what some of these changes are going to make, I won't go like in depth on every single parameter, just because there's a lot and it could be completely overbearing for a first time seeing all this at once. So I would instead say that the quick start guide will be the best way for you guys to familiarize yourselves with the counting parameters. It will define each one of these counting parameters, tell you how they're going to adjust your counts, and then I would recommend just doing some plate scans, loading those plates into the counting software, having the quick start guides brought up next to you, and then using those to kind of play around and get a feel for how it's going to adjust your results. So, but just going over some of the main ones. Sensitivity, that's right here in this adjust sensitivity window. Right now we're set to 145. Like I was saying, if I increase this, it's going to increase the spot detection. So I don't even remember what the previous spot count was, 82. So if I increase it to 175 from 144, now we go to 106. Just looking at this, I can see that this is too high of a sensitivity for this particular plate, because you'll notice that once you start to increase it too far, the outline of the spot starts to get further and further away from the actual spot itself. I typically like to see that outline just ever so slightly off the edge of the actual spot, or just encircling it nicely around the strong.
But I see some
center.
spots like somehow missing. Like for example, I don't know if these
Yeah.
are actual spots.
I mean, that would be, I guess, for you to decide if that were your particular
Yeah. So now
asset.
they are in. Some of them are included now.
Yeah.
So,
You can see the higher I set that, the
Mm.
more likely it's going to be to count it. Now you can see some of those really faint ones, they're being outlined in white. That's because they're being deemed too small to be factored into the that overall spot count per the gating settings. So if I wanted to adjust the gating settings, I could go to this advanced tab and then adjust my minimum spot size threshold. And so if I were to say drag that all the way to the left, that's just essentially telling the software that no spot is too small to be considered a spot. Everything that it sees, it should count as a spot.
Yeah.
So now if I click count, it's no longer outlined in white. But that, yes, what you're seeing there, those very faint spots, again, for your particular application, that's going to be up to you to decide whether that actually is a spot or not. And if you deem that it is a spot, it's just going to be trying to balance not increasing it so high that it's starting to. It's not necessarily a bad thing if these outlines start to creep out from the edge of the spot, but what will happen is like this. If we have there's like 3 spots right there, and they're all close together. Now that we've increased our sensitivity to try and pick up some of these fainter spots, it's now counting all 3 of those spots as one singular spot, which I don't want to do. There's a couple of different ways you can account for that. Now, I just backed off the sensitivity, and now it went down. It went back to counting individual spots. There also is this spot separation parameter. that's a measure of how likely the software is to split those closely related spots up into multiple spots or group them together and consider them one. The higher I set that parameter, the more likely it's going to be to group them together into one singular spot. The lower I set it, the more likely it's going to be to break them apart. So if I had a lot of spots that were close together, then odds are I'd probably want to set that to something like 0 or 1. And then I'd have a little more flexibility with increasing this sensitivity. Yeah, so now I can set the sensitivity. I'm counting those really faint spots, and I'm still individually counting those close spots over there. So, sometimes you'll have a buildup of spots on the edge of the well called edge effect. There is this edge effect compensation button, which will reduce the sensitivity at the very edge of the well to try and negate any edge effect spots that you have popping up. However, typically it's recommended by our scientists to use the counted area percentage and just reduce this to something, say like 90%. So instead of counting 100% of the well, we're only counting 90. And then if we couple that with this normalized counts button, it's going to truly count 90% of the well, but then it's going to try and statistically apply that 90% spot count to 100% of the well and estimate how many spots you would get if you were to actually be counting 100% of the well. So if I click count now, you can see my spot count's 116 with an asterisk. That asterisk is indicating to you that that's not a true spot, 100% spot count. Something is being estimated or normalized, and that being this 90% area here. So
this picture, so when you had scanned it, we had that red outline that didn't encompass the entire well. Is this picture that entire well, or only what was in
it's the region of interest. Yeah, that red outline.
Just the red.
Yep.
Okay.
Yep.
So we've already lost essentially 10% of the outside of that well.
That has been compensated by multiplying to a factor.
Well,
So you would get an estimated number of the total area.
So I was pointing out the region of interest radius setting within the capture format settings. That is set up specifically for a 96 well plate. All or most 96 well plates, to my knowledge, will have the same dimensions.
Yes.
So, like I was saying, even though it looked like it wasn't that red region of interest circle wasn't on the very outside edge of the well, that's because a lot of the edge that you're seeing there is the reflection of the actual well itself. It's not actually the true well bottom.
It's like part of the walls as well, right?
Yeah.
Could be part of the walls, not the actual bottom of the well.
Correct.
Where you are looking
Yeah.
at.
So you're seeing mirrored images of spots that are already in the wells. So yeah, the region of interest should be set on 100% of the actual well. Anything you're seeing outside of that red circle is really just reflection from the wells itself. So, diffuse processing, that's kind of like the normal versus diffuse object type option, just on a less significant basis, I guess. It's set to normal by default. If we had small spots, but we didn't think it was justified in reducing it to something like the detailed option up here, these object type options will make significant changes. Like when you change that, it will significantly change the way it detects spots. So if we didn't want to make a significant change, but we felt that the detection was just a little off for the size of our spots here, then we could reduce this to something, say, small. If we had more diffuse spots, then we could increase it to something like largest, or largest +1. But for this plate, normal seems to be pretty good for our reference plate, so I'll leave it as it is. Yeah, the advanced tab, gating settings, like I said, I already pointed those out, minimum, maximum spot size. If you have spots that are too small, they'll be outlined in white. Now if you have spots that are too big, so I can show you that here. I'll reduce this maximum spot size. This is a histogram distribution of the actual size of the spots in the plate. So, and then I can visually see where my gating settings are by these blue bars here. So if I want to gate out just the largest spots of the well, I can drag that down to there, click count, and now you can see the 2 largest spots in that well are being gated out per the gating settings. Now, by default, it's not excluding these from the spot count. If I go back to my counted area percentage, you can see even though I set this back to 100, I shouldn't be normalizing anything. I'm still getting that asterisk, and that's because these, instead of being ignored like those small spots were, are now being estimated. So since they're oversized, they're considered oversized spots per the gating settings. The software is trying to come up with a statistical estimation as to how many spots would fall within those areas, and that's why you're seeing that asterisk for the estimation going on. So if you wanted to change that, if you wanted to ignore oversized spots, you could come to the settings window, overdeveloped area, settings, and then oversized spots here. I just check ignore, and now it's going to completely ignore them instead of trying to estimate them. The difference between estimate and normalize, the way it's been described to me, is just that when you use estimate, it's going to take the size of the spots outside of the oversized spots and use the spot sizes to estimate how many spots would reasonably fall within those areas. If you're to use normalize, it's not going to take the spot size, but rather the like density of the spots that fall within that well, and use that information to calculate how many spots would fall within that area. I don't know how accurate that definition is. I'm pretty sure that information's in the manuals if you need a more specific definition, but that's, I believe, the gist of it. So, all right. Let me access it. Do you guys have any questions about counting parameters?
You did that for only one well, so is there a way that you can apply this to all the wells and then it will be done automatically?
This will get applied to all the wells across the plate. So the idea is, instead of just looking at one singular well, you're going to make some adjustments on that one well, and then you're going to jump to another well, use those, do a test count with those same parameters, see if it's counting that well effectively. If it is, move on to a different well. Maybe, as you can see, our reference plates are set up so that the left side of the plate, there's fewer spots, the right side of the plate, there's more spots. So if we were to go over here, set up our parameters on this left side, while it might count well on these less dense wells, if we come over to the ones with more spots, then maybe the results would be a little skewed. So it would just be about balancing the results so that we're getting good results from all wells across the plate. But yeah, these parameters here are just applied uniformly across the entire plate. So if I was happy with those results and I wanted to save this template, I would go to the Select Wells tab and click Save Counting Setup and Parameters, and then just type in a counting template name and click Save. And then from then on, every time I load into the counting software, if I go back to that load parameters, then you're going to see that template appear here in the template repository, and I can just quickly load that and not have to worry about setting up everything from scratch again. So another option on the Select Wells tab is if I don't want to count the entire plate. So right now, all 96 wells are being counted, or are going to be counted once I actually start the count, and that's indicated by the little C up in the top right corner of each well. I can deselect the entire plate by selecting this little square up here. And then if I want to just select individual wells, I can just come and click on them. And then that also applies to rows and columns as well. Same way it did in the counting software. So you have that option if you don't want to actually count the entire plate. I'll just count every other well. And then once I'm ready to actually start counting, go to the Start Auto Count tab, click Start Auto Count, and then it will actually start counting the plate. Unless you have like a really good assay with that just generates like perfect images and stuff like that, odds are you'll need to make some adjustments. You'll have to go back and forth sometimes between scanning and counting to get optimal results. I think I mentioned earlier, but like if the color of your background is too strong, it's going to be really hard to set counting parameters such that it's not picking up any of the background and considering that those as spots. So if you're having that happen and you're not able to compensate for that by adjusting the counting parameters, you might just have to back out and go back into the scanning software, adjust some of your image settings, specifically for that scenario. Running a white balance, adjusting the RGB values would be the ideal way to account for that, and then rescan the plate, come back into counting, and then try again. So it really is just a trial and error sort of thing. But that being said, once you put in that time and made those adjustments and got it working, not only across one singular plate but across many different plates, you're able to just save the scanning settings, save the counting settings, and never need to adjust things as long as you're running that particular assay. You could just quickly, you could even go into the scan and count function and just do both steps at the same time without worrying about adjusting exposure and RGB and then adjusting sensitivity and stuff like that. So yeah, that's the end goal here, is just to be able to optimize it so that you don't need to make any of these adjustments unless you're creating a new experiment. So once it's done, it just tells you that it's finished, tells you how many wells it counted and how long it took. Asks you if you'd like to set up another count. If you guys have any questions about counting, I can go back into a different plate. If not, we can move on to quality control now.
And the data is exported like as an Excel.
Yep. Yeah, I can show you the export file. Just look out here. So typically, something we recommend, like there's nothing against going into File Explorer and opening the files that way, but you'll be able to get to all the same information via managed data, which I'll go into later. But if you want to see the file output, just go to File Explorer, computer, navigate to the place that you saved it, plates, ref test. So this ref test folder, that's the scan folder. Before we just counted, before we did that start auto count, this counted folder would not have been there. It would have just been these individual well images. So there's A12, some text files, audit trail. Scroll all the way down to the bottom, and you have JPG and a TIFF file. Those are overview images of the entire plate. Some XML files that contain some information about the actual scanning settings. And then if we go into the counted folder, now we have our individual images but with the counted overlays on top of them. Another audit trail, some text files, and then we do have the TIFF and the JPG file now with the overlays on top of them, and then the Excel file. So the Excel file this contains the information regarding the actual counting parameters that we set. So our sensitivity is 171, our gating settings here, spot separation was 1, etc. And then various statistical pieces of information. We've got our spot counts here. Anything with a -1 just indicates that the well wasn't counted. Mean spot sizes across each well. Histogram distribution of the spot size. Well areas covered by spots, so percentage that was covered by spots. And some other pieces of information as well. So generally, in my experience, that has been all the information that customers have needed to use. But if you need more data, then like I said, that statistics software will help you with some more statistical information. So, all right, so I'll click quality control. No one else had any other questions about counting, right? So QC, just gonna add my plate the same way I did in counting. So click add plates, go to CTLIQ, ref test, check the box, click select, and click start QC. So now it generates this overview of our counted results, and then we can go into individual wells and make adjustments as needed. So I don't see any wells here that have debris in them that would need removed. So let's just pretend. So I will double click a well to go into quality control mode for that particular well. This remove spots option and manually remove option are the ones that I like to point out. Remove spots will do what it says. I'll just be able to manually remove a spot. Manually remove, that's going to be manually removing an entire area within that well. So if I check both of those boxes and click count, you'll see it's going to ask me to manually select any bad areas. I'll select yes, click OK, and all I'm going to do is I'm going to keep the left mouse button pressed down while I drag out just an arbitrary area in that well, release it when I'm finished, and then right click, and then it will ask me if I want to select any additional bad areas. Select no, and now since I checked the remove spots option, it's going to ask me if I want to remove existing spots. So to do that, just hover over the spot that I want to remove, and it's like a triple click, or you can one click, pause, another click, and that will remove it too. So it's like a delayed double click. And then now you can see when I do that, it removes those spot outlines. Then once I'm finished, just right click, asks me if I'm done with the spot removals, select yes, and then you can see those were the spots that I removed, and then that was the area that I removed as well. 126 with an asterisk, because while these are completely ignored now, this area was not ignored. It was set to, I think it was either set to estimate or normalize. So instead of removing the area and ignoring it altogether, it's removing it and still trying to estimate how many spots would fall within that area if it were to have been counted. That would be for like if you had like a hole in the membrane of the plate, and you can remove it and you could still theoretically come up with a spot count for 100% of the well, even though, you know, 25% of the well was missing or something like that. So now it just asks me if I want to accept the value. I'll select yes. It will annotate it, so that's what the A11, A4, and A3 mean. So if I go back into here, if I go to actions, view annotations, here's a list of all the existing annotations that can be applied to a well. A4 was spots removed manually, A3 was manually removed area, and then A11 was just a calculated count, which just means that I recounted it in some way. So, and then apart from just removing spots and removing area, you also have the ability to adjust all the same parameters that we had in the counting section. So if I were to just go to adjust parameters, now I have all of those same parameters here in quality control: sensitivity, spot separation, diffuse processing, etc. And all that will do, it will change whatever parameters that I change here just for this one specific well and nothing else. So if I were to do that, let's say I wanted to decrease the sensitivity to 160. Click count. It's going to come up with 119. It overwrites my, I would have had to have done the spot removal and the manually removed area at the same time if I didn't want it to overwrite that. But if I were to do that, and then I wanted to, say, apply this sensitivity change to like a group of wells, not just this singular well, what I could do is I could right click. Now if you're finding that floating window obnoxious as well, you can shut that off by coming over here, clicking off. Sometimes that gets in the way. But if I just right click on the wells that I want to recount with those parameters, I just right click on them and then come over to this recount batch button, click that, and now it's just going to go through and apply that sensitivity parameter to those handful of wells there, and come up with the new counts for those. And then A12 is the only annotations. It's all I did was I performed a new count, so I didn't remove area and I didn't remove spot. So the only other thing that I would think to go over would be to change the double click action. So if I had like some negative control wells or something, for instance, that sometimes, again, you might get something in a negative control well that's not necessarily a spot, but the software picks it up as a spot. If I want to just quickly set those control wells to 0, I could set the double click action to 0, and now I could just come and I could double click on the wells that I want to set as 0, I believe. Yeah, you can click the click the column, and that will just automatically set everything to 0 as well. And not only can you set to 0, you can set it to rejected if you didn't like the results or there was some discrepancy within one of the wells. TNTC, too numerous to count, so if there's just a complete overabundance, maybe it's positive control well, complete overabundance of spots, the software, if you got like 2,000 spots or something like that, the software is not able to sometimes distinguish every single spot in the well if there's just too much going on. You could set it to TNTC, not done, or accept count are also options. So
I have a question about set to 0. So let's say that your control wells had some spots that were picked up by the software. Would that be subtracted from other wells? Like, is there a way that you can, because these false, I would say false spots would be showing in other wells as well. Is there a way, like, you know, it's like subtracting blank from ELISA reading. Does this apply here, or?
Are you saying the same false positives would be showing up in all the wells across the plate, or?
Yeah, because if that negative well is not supposed to be showing spots, but it's actually showing, so this means that other wells, even though they are not controlled, could be showing as well a false positive. So is there a way that you can subtract whatever,
like the same object from every single well across the plate? I can't think of something off the top of my head. The only example I was thinking of there was like I said, like debris that got into a negative control well, like a piece of dirt or a hair or something like that. Obviously, that's not going to show up on every single well across the plate. It might just be that singular well.
So the idea of zeroing is just, you know, this is a control plate. It shouldn't have any spots. That's it.
There might be other applications in which you would want to zero that. That's just something I don't have the ability to speak to because I don't conduct experiments like this. Negative control wells are just the easiest thing that I could think of, but I'm sure there's other. That's not just specific to that. It might not necessarily be a negative control well. There just might not have been a response for that particular well for whatever reason, and you still might want to set it to 0, which you could use the set to 0. But I can't think of a. To answer your first question, I can't. I don't think there's an option to. Because like you're saying, the same spot is mirrored in each well across the plate, or just the same
Yeah, I
thing
mean,
causing spots to pop
theoretically,
up?
it can't happen. It's not like, I understand.
Yeah, it'd be super weird. Unless,
Yeah.
if you start to see that, that could be an indication of a problem with the actual machine, actually. If you see a spot,
In every single well, like
there's probably something on the camera, and that's causing it to. There's been instances where I've seen like a piece of dust or something on the camera got on the lens, and then you're going to start to see that in the exact same spot across every single well on the plate. That would be something you would want to call us for, and then or get a can of compressed air and stick it in there and see if you could get it out yourself. But it might be something you want to call us for if you start to see that. So, but yeah, I can't think of any other instance in which that would happen. So, but yeah, that's quality control. So, if there's no questions about that, I'll go on to manage data next. Good on that.
I do have one question.
Yep.
So you took out that area, you said ignore that area. Can you apply ignore that same area in all the wells?
No, that is just because of the nature of like are you talking about you're just talking about the manually removed area, not the manually
So you
obviously
did
the
that-
manually removed spots is not something you could apply to all wells, since the spots
So
could
let's
be
say
different.
for whatever reason you had a hole in the upper right hand corner of every single well. And so you wanted to ignore that particular 5% of
Yeah.
the well in every single one.
Not with that tool that I just showed you, I don't think. I can test that, but I can't test like that. I'm pretty sure that doesn't work like that if I were to recount that. If I wanted to, just a little off-topic disclaimer, but if I didn't want it to be estimated or normalized, then I could switch it to ignore right here. So that's where you do that. But all right, let's try this. Oh, fucking yes.
It's like recount batch. Using that.
Yeah, the other options here are just if you have like a list of plates, then it would apply the changes to all the plates within that experiment, within that list of plates. But see, I don't think that's gonna recount with no. But that's a good point. Like, I mean, that is something that I feel like you could theoretically make the
think
argument should be something
Yeah.
you
You
could
could,
apply to
uh,
multiple
Inject
wells.
something and you had a-
You could adjust it in the scanning, right? You could do that in the scanning. You could exclude that part in the scanning process. I
What do you
think
mean by that?
So instead of scanning the whole well, maybe you could exclude that area from scanning, or you can't. Because you can select, right? You can select, or is it a circle? Like you can't have like a
Yeah,
regular-
it's just the circle.
Just
you
a
couldn't
circle,
couldn't
right?
exclude a certain portion from being captured in the image. It's going to capture the whole thing.
Hmm.
What like example would you be thinking
don't
of
know.
that you would?
I don't know.
Because I get it. Like
Possibly
it
with
makes more sense. Yeah.
The multi-channel pipetter, if you like hit the wells,
In the
hit
center.
the bottom
That's a good
and
point.
ruin the.
And you are consistent in it, yes.
Yeah. That's true.
But you could see how you could do it across like all 8.
Yeah.
Like,
No, it makes sense to me. I always just kind of roped it in with the logic of the manually removing spots and why that wouldn't work if you were to apply that. But I agree. Like if it's a particular area that's being damaged or whatever on a series of plates, then that could reasonably happen. That's something I'll have to ask about. I don't know if like I said, I'm almost 99% sure that option does not exist currently in the software, but it might be something that they would consider including in the future if we felt it was necessary or advantageous to someone. So Alright, so once I'm done, I'm just going to click Finish Plate and go to Project Overview. And then it's going to ask me if I want to finalize the quality control step. So clicking yes will just mark this plate as finalized, just to let your colleagues know that you've done quality control on this plate and it doesn't need to be further changed. If I select no, it's going to say QC started but not finalized. So it will save the changes we've made thus far, but allow you to open it up in the future if you want to continue making some adjustments to your results. So I can click yes, click exit, and then click Manage Data to go to Manage Data. I will click Add Plates. Same logic here. Ref test, check the box, click Start. So like I said, Manage Data just consolidates everything into one little suite, and it will allow us to view our scanned images, view our counted images. Oops, I don't mean to do that. And then view our quality control data. So there's the quality control wells. For counted and quality control data, if you go to the Show tab, you have the Excel file that got generated. So this is the same quality control file. Well, this is the quality control Excel file, not the counted Excel file, and that is indicated by those red outlines. Those are the wells that we quality controlled, but all the same information, so well areas covered by spots and stuff like that. For quality controlled and counted data, you also have this FCS file content window, which will give you a bunch of statistical information that I guess goes hand in hand with flow cytometry data. I don't know much about, but there's a lot of information there for one singular well. So if this information is of any importance to you, it exists. So like right now, it's a graph of the center of mass, but you have several different options here. And again, this is just for the one particular well that I selected, or I had highlighted, which is D2. So that exists if you want to use that. The other options in the Show tab are really just overview images and stuff. So we've got an overview image that we can export it to PowerPoint and print it. We've got an audit trail to show what's been done to the plate since it was first scanned. And then really the only other thing I like to show is just the ability to export specific wells. So we can export an individual well. If we want to export the entire plate or print it, we would do that. Or if we want to export a group of wells, we can click Save Export Group of Wells. Select between our scanned, counted, quality controlled data. And then if I double click, you can see it's adding each one of these wells down here into our little well survey preview. I can adjust how many wells are added by the number of columns and rows. And so like if I wanted to just compare those wells counted versus quality controlled, I would add them all to this, click next. I can assign a title, just leave it as generic well survey. And then I can copy it to clipboard, save it to file, export it to PowerPoint, or print it. If I click create, while export to PowerPoint is selected, it just exports this little PowerPoint overview of those wells that I selected. So, and that is the extent of managed data. Really not. I didn't mean to get out, but do you have any questions about anything there? Not much to it. I mean, it was just a way to view the data. So, all right, let me exit. I was in the Biospot window, so if I switch suites to Immunospot SC, there's that Qualify Analyzer thing that I was talking about earlier. Well, that's still in the machine. I won't even open it because it's literally 2 buttons. It's just eject plate to allow you to eject and load the plate, and then start qualification, and that's the extent of the window. Once you click start qualification, it takes, like I said, 20 to 30 seconds about, and then it will just tell you passed or failed. And then, yeah, so totally optional. You don't have to use it. But
I
if
mean-
you choose to use it,
Like it works as some sort of calibration.
it doesn't. I won't call it a calibration just because it's not going to change
It's not gonna
anything.
change anything.
Yeah.
Okay.
It's just going to confirm to you whether or not the machine's working as it was whenever
And
we
you use
first
that
ran
reference
that
plate
reference plate. What's
for
that?
You use that reference plate for
Yeah.
that? Oh, okay.
That reference plate was scanned and counted 5 times before this machine got shipped to you. And then I just ran it here on site. It passed, and then like I said, you can use it.
So maybe every once in a while you can
Yeah,
just
I mean, it doesn't
run
hurt.
it to make sure that a machine is working
Yeah.
properly and
Once a month or something like
Yeah.
that.
Yeah.
If you're not using the machine, then of
Yeah.
course you don't have to use it. But like if you're hopping on every couple of weeks or something, it doesn't. Like I said, it takes a very short amount of time. So if you want to just pop it in there and run it before you're starting things, then it definitely doesn't hurt. That plate will expire. It was a year from when it was set up, so the expiration date on it was September 2024, the end of September 2024. At that point, it will start to notify you when you get into the software that your plate's about to expire. At that point, you can either let it expire and don't worry about it, or you can ask us for a new one, and we can send you a quote for a new one. So.
What's the difference between the different suites? So we were on BioSpot, now we're on Immunospot.
Yep. So Immunospot SC is going to be for single color visible
Oh,
light
okay.
assays.
Okay, that's it.
The counting, quality control, managed data steps are almost exactly the same as they were on BioSpot as they are on Immunospot. The only difference between counting between BioSpot and Immunospot are your object type options that I was pointing out to you with BioSpot. With BioSpot, you had a lot of diffuse options. You had the ring diffuse, inverted ring diffuse, stuff like that. With Immunospot, since it's not used for viral plaque assays, you only have like normal and then inverted options. You don't have ring diffuse options. It's really just like normal detailed, which would be for very small, inverted, and inverted detailed, which would be for inverted really small spots.
But
So-
theoretically, you could use that plaque assay on either one of these. You just have the more limited options.
Yeah, you could. If you're doing a plaque assay, I would just always say default to BioSpot, just because it is designed with plaque assays in mind. From like an algorithmic spot counting perspective, the way the software devs created that software was with the intent to accurately count viral plaque assays. And typically with viral plaque assays, the nature of the spots themselves are a lot more just random. With Elispot, visible light Elispot assays, you tend to see spots like what we were seeing in the reference plate, which are just very uniform circular spots, whereas in a lot of plaque assays that we see, they're not circular whatsoever. They're all kinds of shapes and sizes. So that's something that, while there's nothing explicitly in the software, like an option to account for that, it's something in the code built into the actual software that's just going to be better handled within the BioSpot software. But yes, you could theoretically count a plaque assay in Immunospot. So, like I said, count, quality, the analysis functions are virtually the same between both. Just the object types are a bit different, and the algorithm is different. The scanning software, however, is entirely different. So, would you like me to go over the scanning software of Immunospot as well, in case you go over the into the yeah? Okay.
Since we're recording.
Yeah.
So
all right.
I missed the beginning of your talk. This instrument is able to read the fluorescent spot for 4 colors.
More than that.
More than that.
Yeah, I can confirm once I click scan. I'll show you how many
Because we
colors
have
are
already
actually
had
there.
the kit for fluorescent spot.
From
With 4
CTL?
colors. Yeah.
Okay. Yeah, it can. it can do
12 maybe.
yeah, but a lot of them are just different shades of red. So really, there are 4 main colors. There's like blue, yellow,
Okay.
green, and red. And then it's like a lot of
That sounds good.
variations of red, but and then for this software, I'm gonna talk both about single color visible light scanning, but I'm also gonna talk about fluorescent scanning as well, because while I clicked scan from the Immunispot SC suite, if I were to have clicked scan from the Fluoro X suite for fluorescent assays, it's going to take me to the same piece of software. It's going to start in a different configuration, which I can show you how to change. You can just change it from the interface, but at the end of the day, it does open the same exact software. Okay. So this is what's known as Immunispot Analyzer scanning software. So whereas with Biospot we were using the ImmunoCapture software, this is Immunispot scanning software. Down here is your main scanning window, I guess you could say. No like image adjustments are going to be made down here. It's really just selecting the plate type that you want to scan with and starting your scan. You can navigate to various wells on the plate. You can see that it automatically is set up so that when you navigate to a new well, it does not an auto pre-alignment, but an auto center. You can see it move ever so slightly every time it goes to a new well. That is just a feature of Immunispot itself. It's always going to do that. Auto center on. It's always on by default for visible light assays. Now this will not be on if we're doing a fluorescent assay for the reasons that I gave earlier, where it can't see the edge of the well effectively in a fluorescent application. The preset plate types option here, that is, think of that the same way you were thinking of the capture formats. It contains all of the physical settings of the plate you're about to scan, the image settings, the alignment settings, zoom and focus, stuff like that. So you always want to make sure that your preset plate type is selected according to whatever plate you're about to scan. With ImmunoCapture, we had the ability to duplicate capture formats and just add essentially infinitely to the list that we had there. With Immunispot, we only have 4 existing templates that you can use per configuration. So I'll get into the configuration thing in a minute, but just keep in mind that these 4 are the only options that you currently have to choose from. I think there's a way to add more, but I'm not even sure how to do it. I think you have to like adjust some code or something like that in the actual file. So if you need more, let us know. But this is what you're working with for now. So to start, Millipore MSIP4W. Since I have the reference plate in there, that's on an MSIP4W plate. That should correspond nice enough for this particular plate. Again, these are just generic templates that were set up at CTL. These ones, in fact, are just empty templates for you to create, but don't worry about overwriting these templates if you need to make changes. Whereas with the other software I was telling you, duplicate them, there's no way to do that in this software, so feel free to adjust as needed these plate types. The configuration, each configuration is going to have a different set of 4 plate types associated with it. So right now we're in the Elispot white plates configuration. So that's going to be for Elispot assays that are using white opaque plates. If we switch to Elispot clear plates, give it a second, and it's going to be giving us 4 new plate type options corresponding to Elispot assays that are run on clear plates. So instead of MSIP4W, now we have MSIP45, which is a clear plate. As you can see, the image is completely different. And we also have Maha CTL tray, and then just generic number 3 and number 4. Again, they're free for you to change however you want. With the clear plates, like I was kind of saying in immunocapture, typically when you're using a clear plate, it's better to use the bottom light instead of the top light to illuminate. As you can see, it just automatically switched when we switched to the Elispot clear plates. Your visible light options are top, bottom, and since we're on clear plates, we're using bottom by default. Now you can switch that to the top. If you notice, I switched it. It doesn't update the image. That's because it is just a static image. So in order to update the image, I need to come over here and click grab single image. Now you can see the image is completely overexposed because this plate is not really set up for, or this plate type is not set up for the top plate. Switch back to that. The other options, Biospot clear plates. That would be if you had, if you wanted to scan your viral plaque assay in this software for some reason and didn't want to use immunocapture, then I guess you could use this Biospot clear plates configuration, create a plate type in there, and then open those scanned images up in the Biospot counting software. Fluorospot is going to be for fluorescent. So if I switch this, it's going to drastically change the interface. Not drastically, but right now, these options are grayed out, and these options were grayed out. No, they're not. These are your filters, your fluorescent filters. These are your fluorescent LEDs. Don't really need to pay attention to these so much because these are automatically set according to the filter that you have selected. This is really the only thing you need to pay attention to. So I assume that 4 of these filters correspond to whatever kit you bought.
I think you have a lot. So BI. I think you should. There should be in there, like, you know.
Oh yeah, absolutely.
We just started changing the names of these. Actually, we used to name them corresponding to the wavelength of light that they emitted. So this would be like 440 or something like that.
Common fluorophores, yeah.
Yeah, but now they started naming them differently, which I'm not familiar with. But fundamentally, it's still the same. So this is the blue filter. This is yellow or green? I think it might be green.
That's the green.
Yeah, this is green. We have a visible light plate in here, so you're obviously not getting a response. But this is how you would change the filters by selecting the radio buttons on the left here. This is going to be yellow. And yeah, that's why I was saying there's definitely more than 4 because there's 11 in this one, which is just the Elispot thing is just an empty. It's an empty channel. There's not actually a filter there. But yeah, so if you were doing a fluorescent assay, the interface, all the buttons are the same. This window just opens up, and now.
So for fluorospot, I have to use the immunospot, not the biospot.
Correct. Yep. If you're doing fluorospot from the switchboard, just make it easier on yourself. Switch to the Fluoro X suite and then click scan, and it will default to this fluorospot configuration, so you don't have to worry about changing the configuration. But if you were already in visible light and you wanted to switch to fluorospot, you could do that.
You can choose multiple filters at the same time.
Correct. That's the main advantage of using Immunospot for fluorescent scanning is that you're able to simultaneously scan one plate with multiple filters. Whereas while you do have fluorescent capabilities in the other scanning software, you are only able to scan one singular filter at a time. So you'd have to select a green filter, start a scan, scan the plate, stop it. Yeah, and then it would also make counting different too, because if you open count from the Fluoro X suite, it looks for a specific file path output. Like a fluorescent file path output looks different than a visible light file path output because of the multiple filters that you can scan with. So it would just be super confusing if you were to scan fluorescent with multiple filters in immunocapture. So I would just always stick to this. But the way you go about selecting multiple filters to scan is with the checkboxes over here. So If I check 1, 2, 3, 4, all 4 of those filters, and then I click Start Scan, type my plate name, select the wells that I want to be scanned, it's going to scan all of those wells with each of those filters. It obviously saves a lot of time over doing individual scans, but it still takes a considerable amount of time just because it's gonna go to one well. Yeah, exactly. It's 4 individual well scans. So yeah,
Does it save it as one file or 4 individual files that have been merged?
So this is what the file output looks like. I did do a fluorescent scan earlier. Fluoro test. So that was what I named the fluorescent scan. And then rather than just going straight into the individual well files or whatever, now I did 1, 2, 3, 4, 5 different filter scans here, and then each one of these contains the individual well image files. So yeah, essentially it's like this ref test, that's a visible light folder.
The merge.
This is the fluoro test. Yeah, this is like 5 different visible light folders within one scan, essentially.
Okay, but you have to run another scan to have the overlay of all colors.
If you wanted to get an overlay of all the colors, that would be, it's something you could do in managed data.
In managed data.
Yeah, when you open a fluorescent file, a fluorescent scan up in managed data that has been counted, there's a button that will pop up called multicolored view,
Okay.
and that will allow you to
Sounds
overlay all the different filters on top of each other. Because it's doing, all it's doing is taking each individual image and
Yes,
putting it on
yes,
top of it.
yes,
There's
yes.
no function within the machine
I
that
know,
physically
yeah.
allows
I'm
it to
just asking
scan.
because if you're getting the website, they usually show the picture.
The
of
multi,
all of
yeah,
them.
the multi-scan filter, yeah. Yep, yeah, that is possible. It's just in managed data. There's also, in quality control, when you double click on a well to go into quality control mode on a fluorescent plate, that multicolored view is also there, so you can preview what it would look like within multicolored view on managed data. So, all right, I will switch back to
How
Elispot.
stable is the color for fluoro spots?
Say that again.
I mean about bleaching. So if you keep just with the filter open, do you lose the intensity, the fluorescence intensity over time, like you have in the microscope, fluorescent microscope?
If you leave the plate in the
Yeah.
in the machine.
But how
That-
stable is the fluorescence? Do you know?
Well, for our specific kits, I think they're relatively stable, but I don't, because I want to say the fluorescent demo plate uses our kits, but I can't say that for certain. That would be a question for whoever you're getting the kits through.
If the machine is darkened inside, it should be okay.
I think, yeah, but usually when you open the filter in the microscope, in the fluorescent microscope, you start bleaching.
Yeah,
Unless you're
so
using-
meaning that, yeah, but I think once it's done scanning, I think the laser will be turned off, right?
Yeah.
Yeah, it's just
It does automatically shut off. When it acquires an image, actually, let me go back here.
So I think as long as the laser is off,
Yes.
then it's
The
dark
point is,
inside.
imagine if you just take a picture and you didn't like it. Are you able to do the same and have the same
So it will be
quality?
bleached.
Yeah, that's
like
my point.
any other fluorescent.
Yeah,
it will be
yes,
bleached.
that's my point.
Yeah, like that's
Yeah, so come over here and take a look. So when I go to a new well, you can see there it engages, takes the image, and then it updates. So then it shuts off.
Yeah.
So
Yeah.
yeah, it shouldn't be bleaching it out in there if you leave it in there. And then on top of that, if you don't use the software for 15 minutes, it shuts. It doesn't. I mean, it doesn't shut the analyzer off or anything. It would shut the light sources off if they were wrong, but for fluorescence, they shut off every time it takes the image. In the other software, it does. In the immunocapture software, it is a live preview, so it keeps the lights on all the time.
Okay.
That would shut it off after 15 minutes, but in this software, it doesn't really matter.
Sounds good.
But I know with our kits, I think they're a lot more stable, but I've dealt with other customers' plates where it's like I get 1, maybe 2 scans out of them, and then my spots are like gone. And so it's like it can be tough time sometimes when you've got plates like that. So, but I don't think ours run into that problem too much. So.
Sounds good.
So, over in this section here, you've got a couple of different image adjustment settings. There's not as many adjustments that you can make within Immunispot as there are in ImmunoCapture. Although you do have the ability to adjust your zoom in Immunispot. So you've got zoom and focus, and you've got exposure, and those are pretty much the extent of the adjustments that you can make. Anything you do here for zoom and focus or for exposure is going to be a one-time change, and then it's going to revert to whatever the default value is that's associated with the plate type that you have selected. There is a way to permanently overwrite that, which I'll show you in a minute, but just remember that right now, if I adjust these, it's going to be a one-time change. So, like focus, drag the slider bar the same way it would work in ImmunoCapture. Zoom, drag the slider bar, it's going to zoom in. And if I click default, it's going to return everything to its default position. Find focus is an autofocus option. For Immunispot analyzer scanning for visible light plates, and I want to say for fluorescent plates too, it auto exposes on every wall across the plate. It's generally faster than it is with ImmunoCapture, so it doesn't add that much time. But if you want to overwrite auto exposure and just do a manually fixed exposure yourself, you would come over to this fixed exposure window, check no auto exposure, and then use the gain and time sliders to either brighten or darken your plate. Generally, the advice that our scientists give, I believe, is I think this is for fluorescence though, so I don't know if this really applies to exposure, but typically what I've been told is they like to use the time until it is maxed out, and if you need to make further increases, then start using the gain, but start with adjusting the time and then move on to gain if you need to do that. For visible light plates, honestly, I think auto exposure works pretty well. So just leaving that unchecked and letting the software handle it is usually the way to go there. So, for fluorescent assays, obviously your settings will vary based on the filter that you have selected, right? The zoom, it's not going to vary. The zoom is going to be the same across all filters. The focus, that could potentially be changed on a filter by filter basis, because green spots, generally those are really nice and bright and distinct, whereas yellow spots and our demo plates are usually real small and fine. So they're going to require varying levels of focus to get a clear image of. So focus would be something that would need to be adjusted on a per filter basis, and exposure would need to be adjusted obviously on a per filter basis as well. So like every time, if you're in the fluorospot configuration, you're switching between filters, you're going to notice your zoom will always stay constant, your focus will start to vary, and your exposure will start to vary as well. But again, same logic applies there. Anything that you change here right now is just going to be a one-time change, and then it will revert after you've exited the software and come back in. So, if you want to make permanent changes and not have to worry about making changes every time you scan a plate, you want to go to Scanning and go to Plate Type Manager. And then this window is what will allow you to, whenever you change these, if you click Finish from here, it's going to save those changes permanently and overwrite whatever you have for that currently selected plate type. This is also where you would do a 3-point alignment like we did in amino capture. So as you can see, we're kind of misaligned by default. Now, like I said, auto center's on here, so if this is A1 and that's all, for the further it is misaligned, auto center and auto pre-alignment are both going to be able to fix that. But if we want to just correct that from the start, we would do the 3-point alignment. So we would go click A1, works the same way as amino capture. It auto aligns. If I need to make further adjustments, I do so over here. I can adjust my step size here to make it go further or shorter. And then when I'm happy with that position, just click OK. And now move to A12. As you can see, it's pretty good with the auto alignment. It jumps right to where it needs to be most times. Click OK, repeat for H12. If it's a fluorescent plate, that would be a good distinction to make. If it's a fluorescent plate, unless you have spots in these 3 corner wells, sometimes it can be hard to see where and even if you do have spots, it still can be hard to see where the edge of the well is. So what I generally recommend is to toggle off the no auto exposure and then crank up the exposure so that it overexposes the well and you can actually clearly see where the edge of the well is. Then align it and then revert it to whatever it was and save the alignment. So H12 looks good, click OK. And once you've done those 3, you click calculate. That goes through, calculates the rest of the wells on the plate, and then it's done. You just have to click finish to save those changes. It also tells you step by step what you need to do for the 3-point alignment here. And it also tells you down here what you need to do if you want to change the lens parameters. So if I wanted to adjust, say, the focus of this plate type, I would adjust it, but then I'd click set position and then click finish. So it says once you adjust zoom or focus, click the set POS in the lens control box and then click finish. So that's how you adjust the focus. For the exposure, again, if I wanted to adjust the fixed exposure value, I would just toggle no auto exposure, adjust the gain and time, and then just click finish. And that's what it would default to anytime you clicked no auto exposure. If you don't want to save the changes, just click cancel. And then so that's manually adjusting or permanently adjusting the scanning parameters for a plate type. Again, you only have the 4 there, but if you don't use one of these configurations, so if you never use visible light clear plates or whatever, and you just want to use this for some light plate templates or something, there's nothing barring you from doing that. You're just gonna have to switch your light source or something like that. Now, obviously the Fluorospot and this Fluorocell option are both not going to work for visible light templates because they're going to automatically toggle on the fluorescent LEDs and stuff like that. So theoretically, for visible light plate types, you have 4x3, so 12 different options that you can adjust there. For fluorescent options, you got Fluorospot and Fluorocell. I don't really know. Fluorocell is for this type of plate layout, so a hemocytometer slide. I don't know, you might be familiar with that, but something like that. Actually, this isn't even a fluoro. Oh, maybe they changed this. 96 watt fluorescent. I take that back. I guess they might have updated this. So you do have a 48 well and a 24 well B Falcon, but really just treat the Fluorocell configuration as another fluorescent plate type configuration. So if you need more fluorescent plate types, you can come into the fluorocell configuration and change this around. Now, you might be asking, what if I'm not using a 24 or 48 well plate? You could switch that here. So if I wanted to overwrite one of those 24 or 48 well plates, or I want to overwrite a 96 well plate and make it a 48 or a 24, or something like a 4x4 or 3x10, then those options also exist. And then the plate name is also within that window, so you can adjust the plate name down here. Any questions?
I have a general question. So let's say, many people want to do the scanning, and I want to do the analysis maybe on my laptop. That software is available to have it on other computers?
Yes, it is. It's an additional purchase, which I don't know how much another copy of software costs off the top of my head. But yeah, essentially, what happens is we'll send you an installer, a USB with software installers on them, and we'll send you two software licenses, which come in the form of just USB keys. Those two keys, once the software has been installed to your laptop, you just have to have those two keys plugged into the laptop or the desktop that you're using the software on, and you're able to use that software as long as those keys stay plugged in. So one copy of software, you could theoretically use it on as many computers as you'd like, as long as the software is installed. You just wouldn't be able to use it simultaneously on multiple different computers unless you bought multiple copies of software.
So two USB in addition to the software already in the machine, right?
Correct.
Yeah.
Yep. Yeah. So let me do a quick test scan here just to show you how to start it. Again, auto center by default is on. It's going to auto center on every well. 3 points only would make it so that it only performed like an auto pre-alignment action instead of auto centering on every well. I'll leave it on auto center. Click view plates, browse plates, save it to that folder. Click OK, and then just create a plate name. Click OK. Just do those columns. Click OK. If this were fluorescent and you selected multiple filters, it would just be A1, scan with the blue filter, switch to the green filter, switch to the yellow filter, etc. Then move on to the next one. Yeah, it changes the filter and then moves on to the next well. Just because there might be a slight discrepancy in the position of the well if it were to move away from that well and then come back.
And
so
then
that
come
would
back.
that would theoretically cause problems with the overlapping of the filter images or whatever. So that's why it just takes all the filter images once it's settled on that position. I don't know if you noticed there was a count cells button on the switchboard on the Elispot SC suite that also is on the Fluorox suite. Count cells is our cell counting software, so that's going to be for any NK live dead apoptotic assays. So if that's something that you guys use, let us know. I don't provide training on that just because it's not something that a lot of customers use. So we have one of our scientists back at CTL conduct the training for cell counting. So if you ever get into that, let us know and we'll give you a training free of charge for cell counting. So, but that is the extent of Elispot scanning. So, any questions? All good on that? Alright. So I will eject our plate now since we're done with this. Do you want me to leave the stuff in the keyboard tray, or do you want me to put it in the accessories box? It's up to you.
I think we can leave them there.
Leave them there?
Yeah, nobody does.
One thing I failed to mention, this thing, for fluorescence. This is a backlight cover, so this just reduces the glare off of this glass glass plate holder.
Mhm.
So if you're doing a fluorescence assay, it's best to leave that in there.
Okay.
It's not going to hurt a visible light assay unless you're using a clear plate and using the bottom light to illuminate it. So if you're using a plate like the reference plate and it's just working with the top plate, this isn't gonna make a difference since it's underneath of the plate. But you'll definitely want to take that out if you're doing a plaque assay or something with a clear plate and it's using the bottom light. So, but the only thing this is needed for is fluorescence applications.
We have the white, so it's okay.
Alright, perfect. Yeah, shouldn't need to worry about it then. And then once you're done in here, just the exit button here will get you out of there. We're still in a Elispot, so if I want to go back to the main switchboard, sometimes that happens. It goes back to the main switchboard. I guess one other thing to point out: when you were in the Elispot scanning software, if you would have went to File, Elispot Preferences, in the first window that pops up, you have your naming mode. So if you ever switch from prompt for plate name to barcode naming or something like that, that's where you do that in the File Preferences section. So other than that, that's about it. So, I don't think you already pointed out the manuals.
And the counting's all the same for that?
It is. Yeah. Well, I can open up the fluorescent counting. The premise is exactly the same. The interface looks a little different for fluorescence counting, but another thing, you don't have to have the analyzer on if you're doing analysis, like counting, quality control, managed data. Analyzer only needs to be on if plates are going to be scanned. So for fluorescence, you only have smart count and basic count. The logic behind both of those applies the same as it did in the other sections. Object type for fluorescence, since you're only ever going to have bright spots on a dark background, you only have inverted detailed or inverted normal. And then a basic count. Load my plate. Make sure I checked the actual I already counted this. So if you've already counted a plate, it's going to prompt you to either delete the previous data or rename it. I generally wouldn't recommend renaming it. I would recommend deleting it, but if you want to keep that original data, I would just copy and paste it to some other location or something like that.
Before open. So
Yeah, before you
copy and
delete it,
paste.
so that you can retain that old copy. The only reason I say don't rename it is just renaming in the software shouldn't be problematic, but renaming outside of the software is very problematic. If you ever rename a plate that was scanned and try to then open it up into counting or into quality control or something like that, the software is going to look for that original plate name because a lot of the underlying files within the folder are named according to that original plate name. Do not get updated if you rename a plate. So it will cause all kinds of headaches if you try renaming plates manually from File Explorer. So I would recommend deleting things if you have to. It was just a test count I did earlier, so I'm not worried about keeping the old data. But so this is the interface. Now all you have to think about is now instead of just setting one set of counting parameters, now we're doing things on a filter by filter basis since it's fluorescence. Since I scan with 5 different filters, I have the 5 different filters that I scanned with here. I can switch between them down here in this filters window. And then each one is going to pop up with a new fine-tuned params box in which I will now adjust all the same parameters that I adjusted in the single color counting software. So all this stuff is the same. Spot separation, sensitivity, it all works exactly the same. The only thing you have to remember is that it's just now being done on a filter by filter basis. If I go to view select wells, this is where I can double click and do a test count. Only one singular spot was counted there. The nice thing about fluorescence is it's super easy to count when you have a nice looking assay like this, so I didn't have to adjust anything and it looks really good. So it's not usually too hard to come up with good counting parameters for fluorescence, unless you've got your yellow spots that are super faint like that. Those can be tough. This is one of those cases in which you might want to try adjusting your object type, which can be done now on a filter by filter basis as well. So that's right here. Inverted normal is what it's set to, but if I wanted to switch it to inverted detailed, I could. So now it's going to be a little more sensitive when it comes to picking up spots. Arguably too sensitive. Try to get that. Let's do actually, I might not want. Yeah. Switch to small. That seems to yeah, this is.
I think this is the best.
Yeah, yellow's tough.
Yeah.
I don't know why yellow always looks like this, but maybe I was using inverted normal earlier and had this set to like 230 or something. Oops. Those outlines are a little too big, so probably.
Yeah, that's good.
I'm surprised that it even picks those spots up because I could hardly even see those.
Yeah. That
They're-
would be my
they're
first
terrible
question. This
looking
is a
spots.
real signal?
Yeah.
Yeah, that's one. Because sometimes when you run a Elispot, a regular one, you
Yeah.
see small dots like that. So that's the first thing that I question. So this is artifact or this is a real signal?
Yeah. No, I guess that's real in terms of our demo plates because that's what they
Yes.
always look like for some reason for the yellow. But it's counting most of that stuff there. So
Yes, for me it's good. There's some missing here, but it's still good.
yeah.
Most of it are
I
covered.
don't even know. I think what? Oh, I guess I can go higher. I thought 250 was max. Not 255. You can see that sensitivity is a little too high.
Yeah. No worries.
Never gonna have
Yeah.
255
We got
sensitivity.
it.
But yeah, it might be tough to get those ones at the top, but I don't know. Still impresses me even with that. So I don't know. But so once you've gone through each individual filter, this window here just tells the software which filters you actually want to count once you actually start the count. So if I didn't want to count all the filters, I could uncheck the boxes of the filters I didn't want to count with.
Just
If I just want to count 2 filters or something. I can also deselect the wells by right-clicking on the wells here. A little bit different than visible light, but same logic. And then just click Start Auto Count, and it will start counting.
the software is gonna show me the number based on the filter. For
The
each
counted-
filter will be one number
The number for what?
for the count.
So you have 100 blue counts.
So I don't have, if I leave the 5 filters open, I don't have 5 numbers in the same picture.
Right. Yeah. Yeah. It's just gonna give you this number right
One
here you're talking
number.
about. It's just gonna give you that
Filters.
one number for that specific filter. Yeah. Now, when you do the
overlap.
overview thing, the overlap, it will tell you inclusive and exclusive spots. So it will tell you which spots are fluorescing only under one specific filter, and it will tell you which spots are what do they call it? Multi something.
Mhm.
I don't know. I'm not a scientist, so. So let's go to quality control real quick so you can see that multicolor view. So the window looks much the same as it did in visible light. My filters were over there, so I can get back here. If I want to switch between one of the filters, I can do that. Now, if I try to switch to a filter that wasn't counted, it will not allow you to open it if it hasn't been counted. And then this is the multicolor view tab here. So if I select that, it's got, so this is the image only under the blue filter, image only under green filter, yellow, and then that's blue and green overlapped, blue and yellow overlapped, green and yellow overlapped, and then all three together. You can adjust the image settings so that if I wanted to bring the green up or whatever, make the green a little more visible, I could do that. And then I could export the image, create virtual plate. I think if I were to virtual plate name, yeah. So this is. Let me verify this. So if you select, so if you wanted all three filters overlapped on top of each other and wanted a virtual plate for the entire thing, select that, and then click to create virtual plate. Select the destination folder where you'd be saving that, and then it's going to export the same, I think it exports the same type of output that you would get from a typical plate scan.
You have the word.
Yeah, so it's
Yes,
the
sounds
overlap
good.
image. And then this is the inclusive exclusive thing that I was talking about. As far as I know, again, I don't dive into this stuff too deep,
Yeah.
but as far as I've been told, inclusive would be spots that only fluoresce. So like for this, they would only fluoresce under the DAPI filter, and then inclusive would be, oh gosh, I'm already getting confused now. Exclusive would be exclusive to just the DAPI filter. Inclusive would be spots that fluoresce under multiple different filters. I think that makes sense. 247 are exclusive to that, whereas 240. Maybe I'm thinking of that wrong. Man, that always trips me up.
No worries.
I don't know. Have you ever heard of it referred to as inclusive and exclusive like that?
No.
No?
No.
You understand what I'm getting at though, right? Like exclusive would be it's saying that there are 247 spots in this well that are exclusive to
Cappy.
just that
Ah,
filter.
okay. Oh, you're okay. I get it.
Inclusive. Okay, inclusive is just. Yeah. That makes
Yeah.
sense now. Inclusive is just that spot count. It's just like the spot count that you got from this DAPI filter. Exclusive means there are 247 spots of the 249 that only fluoresced under DAPI, whereas
So
the
there-
remaining two.
There are two
Um,
spots that you can consider as DAPI positive. So inclusive, they detected all the fluorescence.
So there are 249 DAPI positive. There are 247 that are only DAPI positive.
Yes,
Correct.
that are. This is the reliable value.
And there are two
Inclusive
spots that are
includes-
DAPI plus
Yeah.
something else.
Yeah, inclusive
Correct.
includes
Yeah.
other
Yeah,
stuff.
Yep.
sounds good.
Yeah.
Yeah. Yep.
Yeah,
Good on that?
perfect.
Alright. Like I said, everything else, virtually the same. Remove spots, remove areas, all the same.
Mhm.
Adjust parameters, all the same. You can recount wells by just right clicking them. You can toggle off the floating window. I guess I don't see a double click action ability to change that. I don't know, maybe you can't change the double click action. Maybe that is only a feature exclusive to single color, but for the most part, fundamentally, they're very very similar. So, yeah, it's all good. Yeah, no problem.
This was awesome.
I just have a quick question.
Yeah.
Is this USB stick also a key as well? or-
No, that's mine.
Okay.
That's what I transferred the folder,
Okay,
the
okay.
manuals and stuff to.
You
Yeah.
can leave it here if you want.
I've done that before. That's not the first USB stick that I've left there. So yeah, it wouldn't be the first.
So we don't need to use any keys on this.
Yeah, no. The keys are actually inside of the computer. So
I don't
yeah.
know. I don't know if it's at that beginning. But what is the difference in doing scan and then counting, and then just click scan and count?
Scan and count will just do both of those two steps at the same time to end.
So
and
it's preferable.
by
What do you
yeah,
think?
it's I would say it's preferable once you've done the necessary setup for your scanning parameters and your counting parameters.
Okay.
Until you've done that, you have to go into them individually, because when you go into scan
You
and count,
can adjust.
yeah,
you mean.
you can't really adjust.
Okay.
Can't really adjust things in scan and count. It's just
I get
what
it.
scanning template do you want to select
So-
and what counting template do you
Okay.
want to select.
So you just escape some.
Yeah,
Okay.
you already have to have existing
Yeah.
stuff to do that. So,
Perfect.
but yeah, that is the ideal scenario. Is once you get there,
Mm.
then you can just quickly take care of it with scan and count. So. Yep.
Perfect.
Alrighty.
Very nice.
Apart from that, as far as like maintaining the machine, I always like to power cycle the computer every so often. I know some customers get in the habit of leaving the computer on like indefinitely and never shutting it off. In my opinion, you're just asking for problems. You know how electronics tend to be. Like the longer they stay on, the more likely they're going to be to have issues. So if you could shut the computer and the analyzer off at the end of the day or whatever, that's ideal. If you can't, if you have to leave the computer on or whatever, that's fine. I would always shut the analyzer off when you're done scanning or whatever. As far as maintenance on it goes, I think you should have at least a year's warranty with the purchase of the machine, which comes with a preventative maintenance for a year, for one preventative maintenance during the year. So someone will fly out and do an inspection of the machine, go through, check all the pieces of hardware, like lubricate some of the moving parts in the machine, make sure everything's running smoothly. So I would always recommend taking us up on that, at least for the first year, since you've got it free. The travel charge is not covered with the actual complimentary PM, so there is still a travel charge, but as far as like maintenance and stuff, it is
Mm-hmm.
it is covered by that. Apart from that, yeah, there's really no maintenance. If you ever run into issues, the most likely thing I think you'll ever see are going to be the computer not being able to connect to one of the pieces of hardware in the machine. When that happens, generally it's going to pop up when you're doing that initialization process. After you've clicked scan, it will go through its list, and then if an error pops up, that's usually an indication that some piece of hardware is malfunctioning. If you send us the specific error, screenshot it, send it to us in an email. Usually we can deduce what's malfunctioning, and there's some basic troubleshooting that's very easy to go through with you guys over email or on the phone, and hopefully get it resolved like that. If we ever need to come out though, we can do that as well. But yeah,
Awesome.
that's about it. I think that's all I got, unless you've got questions.
No.
Sure we will when we start using it.
Yeah, no problem.
Yeah.
Yeah.
Very so actually.
Thank you very much.